Good morning, students. How are you? In the last class, we were discussing the case of a moving curved plate, that too, which is unsymmetrical, and the jet of fluid striking it tangentially. We come to know that the force Fx, that is in the direction of motion of fluid, is nothing but equal to mass per second whole multiplied by initial velocity minus final velocity. From the velocity triangle diagram here, it is very clear. Initial velocity in x direction is equal to Vr1 cos theta, and final velocity in the x direction is equal to minus Vr2 cos phi, because it is acting opposite to the direction of motion. It is very clear, right? Next slide. Therefore, Fx is equal to rho a Vr1 whole multiplied by Vr1 cos theta minus Vr2 cos phi. If beta is acute angle, you can see from this figure very clearly beta is less than 90 degree, means it is acute. But from inlet velocity triangle, cos theta is equal to, you have to take all trigonometric ratios and you have to find out the magnitude. Cos theta is equal to Vw1 minus u1. This is Vw1. This is u1. Therefore, we want from this triangle, if you take cos theta, you can find out this quantity, right? This small quantity you can calculate. That is nothing but equal to Vw1 minus u1 divided by Vr1, relative velocity. Therefore, Vr1 cos theta is equal to, just cross multiplying, we will get Vw1 minus u1. Similarly, from outlet velocity triangle, this is inlet velocity triangle, inlet, this is outlet, outlet velocity triangle. Cos phi is equal to, in the similar way, Vw2 plus u2 divided by Vr2. Therefore, Vr2 cos phi is equal to Vw2 plus u2. Is it clear? Next. Therefore, Fx is equal to rho a Vr1 Vw1 minus u1 plus Vw2 plus u2, because minus into minus will become plus. Now, u1 is equal to u2 because we have assumed that the plate is very smooth. Hence, the ultimate expression for Fx, force exerted by the fluid on moving unsymmetrical plate, is equal to rho a Vr1 whole multiplied by Vw1 plus Vw2. Above equation is only applicable, you should remember, it is applicable only when beta is equal to less than 90 degrees, means acute angle, when beta is acute angle. In the similar way, we shall find out when beta is greater than 90 and when beta is equal to 90, then we can come to a general conclusion that Fx is equal to so and so. That when we come, we'll make it clear and we'll specifically say. Okay? Any doubt? No. Very fine. Next slide. if beta is obtuse angle, obtuse means beta is greater than 90. So in this figure you can see earlier this line was here. Barabar? That means now it has been shifted over here so that the beta will become obtuse angle. Beta is become greater than 90 degrees. From inlet velocity triangle, we can get VR1 cos theta is equal to VW1 minus U1 as we did before. Similarly, from outlet velocity triangle, we get cos phi is equal to U2 minus VW2 upon VR2 because now the magnitude of U2 will be much more than VW2. Therefore, we get U2 minus VW2 upon VR2. Therefore, VR2 cos phi is equal to U2 minus VW2. Just cross multiplication. Clear? If you start writing on paper after the class is over, in 10 minutes you can learn this. Just geometry of the figure which you have done in 11th standard. Once the concept is clear and when once you can able to write velocity triangle properly as per the requirement that beta should be greater than 90 degree, then no problem at all. Therefore, Fx is equal to rho A VR1 whole multiplied by VR1 cos theta minus of minus VR2 cos phi. Therefore, Fx, further if you simplify, you will get rho A VR1 whole multiplied by VW1 minus U1 plus minus into minus will become plus U2 minus VW2 because we have found out the value of component VR1 cos theta separately from inlet velocity triangle and VR2 cos phi from outlet velocity triangle. There now, since we have assumed that plate is smooth both at inlet and outlet, the peripheral velocity U1 and U2 will become equal. Therefore, U1 and U2 will be get cancelled away from this equation. Therefore, the net or ultimate equation for force exerted by the fluid on a moving unsymmetrical curved plate will be equal to rho A VR1 whole multiplied by VW1 minus VW2. When beta was acute angle, what we got? Rho A VR1 whole multiplied by VW1 plus VW2. Only sign has changed. All rest magnitude are remained unchanged. So this is the equation for the case when beta is an obtuse angle. Here, beta is an obtuse angle. Therefore, we can write the general equation in general. Therefore, okay, we will consider the third one also. If beta is equal to 90 degrees, you see the figure. Beta is made 90 degree here. All of you can see, understand from the velocity triangle. This is inlet velocity triangle. This is outlet velocity triangle, wherein beta has made 90 degree. Then Fx is equal to, so in this case what happens? From figure itself it is understood VW2 will become 0 because it is 90 degree and V2 is equal to Vf2. V2 is equal to Vf2. Hence, Fx we can write rho A VR1 whole multiplied by VR1 cos theta minus of minus VR2 cos phi. Fx is equal to rho A VR1 VW1 minus U1 plus U2 minus 0. Now U1 is equal to U2. Therefore, we get only VW1 inside the bracket. Therefore, Fx is equal to rho A VR1 whole multiplied by VW1 because plate is smooth, U1 and U2 equal to U1 is equal to U2 and hence both of them will be get cancelled in this above step. Above equation is only applicable when beta is equal to 90 degree means it is a right angle. Okay, now we can conclude in general equation we can write as what? As what? Therefore, in general, force exerted by the jet is equal to rho A VR1 whole multiplied by VW1 plus or minus VW2. Take positive sign when beta is acute angle, it is less than 90 degree. Take minus sign when beta is greater than 90 degree, that is obtuse angle. Put VW2 in the same equation is equal to 0 when beta is equal to 90 degrees. Do you feel it is very difficult? Not at all. Very easy and classical subject. Only matter is you have to understand slowly, stepwise, gradually. You will keep on understanding the things and then you will feel very, very comfortable. It is not at all difficult, very easy and classical too. You have to practice it. Okay, we will continue. After finding out the force, what is our work left with? We are required to find out the work done per second by the jet on the vane. Work done per second, we know force in the x direction multiplied by distance traveled per second, that is nothing but velocity of vane. Work done per second is equal to Fx. Velocity of vane is equal to u because it is moving with velocity u. Work done per second is equal to rho A VR1 whole multiplied by VW1 plus or minus VW2 into U. You have to consider when plus sign you have to consider. You see here, when you have to consider plus sign, when beta is less than 90 degree. That's all the difference, nothing else. Consider minus sign when beta is obtuse. If it is 90, VW2 will vanish. Only VW1 will left in the brackets, within the brackets. Therefore, work done per second per unit mass of fluid striking per second. Work done per second divided by mass of fluid striking the plate per second. Then rho A VR1 whole multiplied by VW1 plus or minus VW2 multiplied by U divided by rho A VR1. That is nothing but mass of fluid striking per second. Therefore, work done per second per unit mass is equal to, further this formula simplified VW1 plus or minus VW2 multiplied by U Newton meter per kg. Here it is, in the earlier step it was Newton meter per second or watt because it was work done per second. Now work done per second per unit mass. Therefore, it becomes Newton meter per kg. So be careful about writing the units and understanding. So here rho A VR1 whole multiplied by, here without rho A VR1 because we are dividing it by mass of the fluid. Next, work done per second by jet of vane. Work done per second per unit weight of fluid per second is equal to rho A VR1 whole multiplied by VW1 plus or minus VW2 multiplied by U whole divided by G rho A VR1. Work done per second per unit weight of fluid striking per second. that will be equal to 1 upon G whole multiplied by VW1 plus or minus VW2 multiplied by U Newton meter per Newton. Is it clear? Unit also? Very clearly it is written and explained. Next slide. Last part, as you are aware, efficiency we have to find out. Efficiency of the jet, we know. It is the ratio of output power divided by input power. Input power is nothing but kinetic energy per second, that we know. Half mv squared per second. Here we have to write half rho A V1 multiplied by V1 squared. That will become half rho A V1 cube. Output power, just now we have written in the previous slide we have seen rho A VR1 whole multiplied by VW1 plus or minus VW2 multiplied by U. Again I am saying plus sign you use when beta is less than 90 degree. Use minus sign when beta is greater than 90 degree. Clear? If beta is equal to 90, then VW2 vanishes. That's all. The change in the formula. Therefore, efficiency of the jet is equal to ultimate formula we get 2 times VR1 whole multiplied by VW1 plus or minus VW2 multiplied by U divided by V cube. Okay. Here rho A VR1 will be get cancelled away. This 2 will come to the numerator. Therefore, 2VR1 rho A get cancelled away. This 2 will come to the numerator. So 2VR1 whole multiplied by VW1 plus or minus VW2 multiplied by U divided by V cube will be left with. That is the ultimate equation for efficiency of the jet. That's all. References, many number of times you have said. Just for the sake of remembrance, you yourself can read all these books whenever you find free time. Is it not? Why teachers should say always these books? How many times we have said that? Is it not? So we'll stop here. We'll continue in the next class, please. Have a nice day. Have a good day. Start practicing at home. Don't neglect. Okay? As much as you practice, so much will be helpful and you will become more confident about it. Okay? Have a nice day.